Okay, this is a tutorial following my how to make a binary to, a base 10 to binary converter, and this is an entire series on how binary works, and I'm going to try to cover it in one video, and if I fail, then I'm just not going to post it. Let me get a pencil. Binary is a series of ones and zeros that computers read out as info, such as a screen or maybe text. And it works off of 1, 2, 3, not 3, crap. Sorry, I didn't mean to say 3. It's actually 4. And then 8. And then that's 4-bit. And then for this, though, I'm going to use 8-bit. It just basically doubles like this. Sorry, I don't have very good handwriting on Paint. 128 being the last one. If you add all these together, you make 255, I think. Or 155, I can't remember which one it is. Yeah, it's 255. And basically, say here would be the ones position, 2, 4, 8, and we're going to use 4-bit for this example. Now when 1 right there is activated, and that would be 0, and that would be 1, and that would be 0. You kind of got this a little bit in my other video that I made about the binary converter and stuff. But what you do is whenever these are turned on, then that means that 1 is part of the value. And when that, since the one where the 4's place is turned on, then that means you do 4 plus 1 to make 5. So this binary value stands for 5. And then you go on with 16 on to 128 in a normal digit, and you can make 125, and if they're all 1 in this example, it would be 15. Which I made a mistake somewhere in that Minecraft video, but I don't understand what I did wrong. Because 3 plus 4 is 7, 7 plus 8 would be 15. So that doesn't make sense why my machine worked incorrectly, but that doesn't matter. And say if all of the values in the binary equation are turned on, because the zeros stand for off and the 1s stand for on, which if you ever learn how a CPU works, you'll see that the CPU bus, whenever a wire is turned has an electric current going through it, that usually means, it doesn't usually mean, it always means that the digit is 1. And that this would equal 15. Although I messed up somewhere in the Minecraft video and it equaled 14 somehow. I must have built something wrong, but and then what this can be used for is an 8-bit, which would be all the way 32, 64, 128, and which you would add in the rest of the binary values. And there's a thing called ASCII, which like a capital A would be 65 in binary, which would be 1 0 8 4 2 and 1, I think. 1 2 3 4 5 6 7. No, that's not right. 1 2 3 4 5 6 7. Okay, yeah. So that was right. And then that would be how you represent 65, and which would also equal a capital A. And I'm pretty sure, let me think here. I have to think about what it was. Yeah, it's 91. Um, the way you represent a lowercase a would be 91 in ASCII, and you'd represent 91 with 8-bit or an 8-bit code. But not in modern day computers, it's 64-bit. So you'd continue the repetition, like the first bit is 1, 1 plus 1 equals 2, which 2 is the second bit. 2 plus 2 equals 4, and 4 is the second bit. 4 plus 4 equals 8, and so on. If you, that's the only way I know to explain it. And each one is 1 bit, and the reason this is 8-bit is because that continues for 8 times. And then the reason that 64-bit continues, 64-bit continues 64 continues this pattern 64 times, and the highest digit you can make in 64-bit is whatever all of every single digit that's used to make up a 64-bit, such as this has 1 through 125 or 128, and everything, all the 8-bit digits added together are 255. All of the 64 bits added together would be, I think it's somewhere in the millions to billions or trillions. I've never gotten past 32-bit because I can't get it that far, because calculators can't do it. Not all calculators, at least. And on paper, I never have enough time. And anyway, also how you can probably look up an ASCII chart for every ASCII code, and another thing you can do with ASCII codes, if it works in Paint, you hit Alt and type in the respective ASCII code for it. Like 71. That's 71. 12 is, yeah, I can't do it there. I gotta get in the notepad and do it. That's 12, 13, 14, 11, 15. And that's kind of how ASCII codes can make pretty much every symbol that I can think of. But yeah. And then if you're wondering, how do binary values create color, such as this logo here, the way that works is there's a thing called and B, which stands for red, green, blue. And what it is when a computer reads out color, or this is how I've always interpreted it whenever I learned binary. And if I'm wrong, please correct me in the comments. But I am positive about the ASCII code and everything, but this part I'm not positive about. And the way I've interpreted the lesson I saw about it is, like, say, the first binary digit that passes through the machine would be, I'm just going to put a random number. Yeah, and say it was this, that would stand for the red column. And whatever that equals to, like whenever you make colors, like edit colors, it's not here. Oh yeah, red, green, blue. And whatever that digit equals to, it enters it into the computer. And the highest is 255. Don't know if that's relevant to 8-bit, but I'm not very, I don't know much about how it translates to color. And the next binary value that will go by will represent the green number. And the next one will stand for blue, and so on. And then, what else? I could probably draw a diagram of the CPU bus I learned from, but the way a CPU bus works is, oh no, that's not good. It would take me a long time to draw it out, and I could probably just link it to a video, but that I don't think I'd get in trouble for that, I'm pretty sure. So you can look up a video on how a CPU works yourself once you've practiced binary bit, and that's sort of the basics of it. And someone just sent me a Skype message, but it doesn't matter. And I guess that's it, I think. Let me think. Yeah, that's kind of it. And I guess Oh yeah. And if you're wondering how it works in computers, most computers nowadays have 64-bit. Mine has 32-bit, but it's a dual core, so it processes around the same time. And the way that you tell how fast that a computer is processing those binary digits is that gigahertz. Although I'm pretty sure that, yeah, that's shouldn't be right. And I'm pretty sure the GPU has a separate gigahertz value, but I'm not positive, so don't take my word on that. And then most people have a 64-bit OS, but I have 32-bit, but it's dual core, so it processes around the same speed, I think. And I guess that's it for this video. Bye. Oh crap. I hope that was recording. Oh crap. That might not have been recording, and you might have been seeing that BRB screen the entire time. I didn't mean to do that. Crap. I'm sorry about that. You didn't see what I was explaining the gigahertz thing. I went back and looked at the video footage. And, what you look at is you go to computer, system properties, and it'll say, most people have 64-bit, but I have 32-bit, as I said. And, that's what determines how fast the binary digits go by. I forgot what the giga abbreviation meant, but I'm pretty sure it's like billion, I think. And hertz stands for like somewhere near a second or something like that. I don't exactly remember. I wasn't paying much attention when I learned it, but that determines how fast the computer processes binary digits, and that determines how many the highest digit it can run, and that's why I only have 4 gigabytes of RAM, is because a 32-bit operating system can only hold 4 gigabytes at the most. And I guess that's actually it right there. Bye.